Alright, pre-calc, here we go with 4.7, inverse trig functions, part 1. So we're going to talk about how we get inverse trig functions and then remind ourselves for functions to exist, they have to have only one x value for a y value, so we need to restrict to make them one-to-one, and then we'll talk about the properties that will create those functions, and then how to find the exact values within those parameters that we're going to create. So to start with, as a quick reminder, if we're talking about the sine inverse of square root of 2 over 2, remember what we're actually finding is an angle whose y value over r value equals square root of 2 over 2. Now there's actually an infinite amount of angles that exist with the y value over an r value square root of 2 over 2. So what we're going to do when we create our parameters is restrict our domain and our range so that we only get one of those angles, and that way we're all on the same page. When we talk about what does sine give us, that means we're going to take the sine of some angle. It's going to give us a ratio with a specific y over r value. Okay, and again, there's an infinite amount of angles that will do that. So in order to find a trig function and give it an inverse, first of all, they have to be one-to-one, which means every x value is going to lead to only one y value, and vice versa. If we're given the y value, it would lead back to only one x value. And why this becomes a problem with our trig functions, if you think about our sine function, if I just draw a really rough sketch real quick here, you'll notice that there are two x values. So these are two different x values at this point that would lead to the same y value. We can't have that if we're going to create inverses, and you could do that anywhere along the curve. There could be two more y values down here, or two more x values that lead to the same y value here. We can't have that. So what we're going to do is restrict the domain of our trig functions so that we would create essentially a window, and on sine it would be something like you see I'm drawing here. Our window there is going to have only one y value for each x value. So to do that, first of all, our sine function window we're going to restrict is going to be from negative pi over 2 to pi over 2, and including both of those. That's an important piece. Our range then is always going to be from negative 1 to 1. So anytime we take the sine inverse of x and then the sine of that value, we're just going to get out the same x value that we start with, provided that our starting x value is in this domain. If it's not, we get out something different than x. Okay. And likewise, if we talk about the inverse sine functions, when we talked about inverse functions earlier in this year, remember domain and range just flip. So now our domain would be negative 1 to 1, and our range would be negative pi over 2 to pi over 2. Okay, cosine function is going to be a little different than that. We're going to go from 0 to pi for our domain, and our range is going to be negative 1 to 1 still. And again, this is going to equal x, provided that x is in 0 to pi. Now, another easy way of thinking about this, or a better way to think about this, if we're going from 0 to pi on a unit circle, we're talking about quadrants 1 and 2. Okay, and going back real quick to sine, probably a good thing to add here. If we're going from negative pi over 2 to pi over 2, this is kind of tricky. We're doing quadrants 4 and 1. Okay, so that's going to give us 4 and 1. So when we talk about sine inverse, we want quadrants 4 and 1 on our unit circle. When we talk about cosine inverse, we want quadrants 1 and 2 on our unit circle. And the last one, our tangent function, is going to be negative pi over 2 to pi over 2. You'll notice now our symbols are different. We're not actually including these two, because if you look at a rough sketch of our tangent function, we have asymptotes at negative pi over 2 and pi over 2. Because x would be 0 there, and we'd be divided by 0, which we can't do. Our range, you'll see for this tangent function, or for all tangent functions, goes from infinity, or negative infinity, to infinity. And so again, this will equal x, provided it's in that domain. And again, this is going to be quadrants 4 and 1 for tangent. And again, if we talk about our inverse tangent function, our domain and our ranges will just flop positions. Maybe. Okay, so our range should be from negative pi over 2 to pi over 2. Okay, so last piece then, how we would evaluate some of these functions. If we say the sine inverse of negative 1/2, now if you look at your unit circle, you'll notice that there are multiple spots where our y value is negative 1/2. But since we want to talk about only quadrants 4 or 1 for sine inverse, and since we're talking about a negative y value, that tells us we must be in quadrant 4. So if we go to the y value in quadrant 4, it looks like 11 pi over 6, but remember we want to be from negative pi over 2 to pi over 2, so we're going to need to say it is a negative pi over 6. Okay, now that changes a little bit funky here because cosine, remember, is talking about quadrants 1 and 2. So even though at the same angle we have a negative square root of 3 over 2, we need to be careful because this has to come from quadrant 2. Since it's negative, can't be quadrant 1, we would be at 5 pi over 6. So cosine is always going to have positive angles, or we should say cosine inverse is always going to have positive angles. Sine inverse could have negative angles. Okay, the cosine inverse of negative 1/2, we're going to look at our unit circle. Again, it's negative, so that tells us quadrant 2, and that's going to be at angle 2 pi over 3. Okay, the tangent inverse, remember, again, this is also quadrants 4 and 1. Since it's positive, that tells us it has to be in quadrant 1, which means when does your y value over your x value get a square root of 3, and that's going to be at pi over 3. And then lastly, our last example, tangent of negative 1. So we know this has to be in quadrant 4 because we have a negative value there. And in quadrant 4, when your y and x values are the same, just negative, opposites of each other, that's going to be at negative pi over 4. Okay, so that's how we're going to evaluate those functions. The big thing you need to keep in mind is what quadrant we're dealing with. So sine is going to be quadrants 4 and 1. Tangent is also going to be quadrants 4 and 1, and cosine will be quadrants 1 and 2. All right, see you next time.